You've been asking for it. EQD have finally delivered. Say hello to the Life Pedal V3. This, of course, was done in collaboration with the band Sunn, or as some people incorrectly say, Sunn. Continue on for the next 10 minutes. This is the third iteration of the pedal. The original ones were very limited, very expensive. As with anything EQD do, once they've reissued them and brought out a new version, along comes a couple of extra little tweaks and usability features that are pretty cool and going to make them a far better addition to your pedal board. Let's open it up, let's take a look inside, and let's actually see what makes it tick as well, because that's what we do here on Tones and Teardowns. We take stuff, we pull it apart, we look right onto the inside because we want to know more than just how it sounds. We want to take a look at its build quality, we want to take a look at how it's done, what corners may have been cut, where things have been made really well, and just to see a little bit more about the equipment that we use. So let's start by opening the box. Nice, nice. I'm always a big fan of stickers. That's pretty cool. And, of course, anyone who knows anything about the original pedals and the description on this one, these are based on a white-faced rat for one part of the circuit. So, of course, why would you not have a rat sticker? Extra sticker from EQD, of course. Throw it on your guitar case, your pedal board case, whatever. They're always good, well worth it. Instruction manual. We'll take a look at that later. Ooh, catalog with all the new products. Of course, the Here's a Meatas fuzz, which we sold so many of them when they came out. Really, really cool. Excellent sounding take on a muff. All the other ones, Hoof Reaper, octave dividers, the Tentacle, of course, and of course the Urac module. That thing is really cool. Can't have a pedal for the modern age without throwing it, of course, in a cloth box. Ooh, there we go too. Look at that. Get ourselves a pick too. Of course, with the two different versions of the cross, as was found on the original one. So the original one only had two switches, that was it. One for the boost, one for the distortion. The octave was either switchable on or off via a switch on the unit. But the new version has three switches and some pretty sweet graphics. So this is in the larger box format, but not as big as sort of the older ones. So this is in line with the Palisades Mega Overdriver in its box size. And of course, you got your three switches in there. So compared to the original, this one does have three buttons. What's cool as well is they're actually EQD's smart switch technology. What does that mean? Tap the button once, it latches onto the next setting. On, off, on, off, on, off. However, what if you only want that to be on for, say, a bar of a particular song that you're working on, right? Especially with the octave. You get up to that passage there, press and hold, and whilst you're holding that down, the effect becomes active. Let go, turns off. Momentary switching. That's been enabled by using a microcontroller and some relays inside. So, starting over here on the right, this is the amplitude control, aka a white-faced rat. Standard controls for said rat, distortion, pretty self-explanatory. Filter, if you're not familiar with a rat, some people aren't, it works opposite to a tone control. So when you're down here at the lowest setting, you've got the most treble. As you roll it up, what's happening is it's rolling off those high frequencies, so it's filtering them out. Get all the way up top, most of that high-end content is gone. Of course, you got your amplitude as well, aka output. You know, more equals louder. However, slight bit of a difference to the original rat is now we've got switchable clipping diodes. Position 1, we've actually got just the op amp by itself, no clipping diodes whatsoever. Louder, more raucous, more raw. Less compression to it as well because you've not got those diodes clamping the signal down. Next section over is an asymmetrical clipping. So on one side, you've got standard silicon diodes, and on the other side, you've got an LED. That means that as the signal reaches one side, it gets clipped at a certain point. As it goes down to the other, it gets clipped at a different point. And so that sounds different. That gives you different harmonic content. Moving over to the third position, that is your stock anti-parallel diodes, one going up, one going down, standard silicon, that's your classic rat tone. Over on the left-hand side, magnitude, simple as simple can be. One button, one knob, FET-based booster. So, turn it up, you get more louder, turn it down, you get less. Of course, you can press and hold, or you can just tap to latch it onto the next thing. Finally, the octave. In version 2, you could blend in the octave control, but you couldn't switch it in or out, and it had no foot switch. Now, you've got best of both worlds. You've got that blend control, so you can blend in as much as you want. And then, of course, you've got your smart switch technology. Tap it once, turns it on. Tap it again, turns it off. Press and hold, and you can maintain that octave for whatever passage you're playing as long as that's being held down. Of course, if you do want, like the original V2, to control it with an external treadle, you can still do that. It's got an expression pedal input, which is cool. So maybe one particular song you want more octave versus less, or you just want to blend it in as a background thing, that option is still there. So let's get this thing open. Let's take a look inside, because since we've got a rat there, we can make a couple of assumptions what it's going to be. Since it's an old school octave type circuit, we can make some assumptions to what that's going to be. And this here being a standard FET booster, there's nothing going to be crazy going on there. But I want to see just how interesting it is inside. Hello, PCB. So straight off the bat, I can already see some stuff which is pretty much exactly what I was expecting, and some things, not quite so much. First of all, these orange things here are the relays. One for each of those switches, controlling the switching of that circuitry inside. So they're just a standard part, easy enough to get a hold of, all that kind of fun stuff. One thing though that is kind of interesting is it's all surface mount. So it's not, it's not through-hole components. So that's going to make repairing more difficult unless you know how to properly work with SMD components. If you don't have, for example, hot air rework and the likes, this of course being an ROHS compliant device is going to be all lead-free solder. So it's not like you're going to be able to just go, all right, cool, I'll grab some leaded solder and go about it that way. So repairability is going to be a little harder. Another thing as well is that with these relays, because say for example the microcontroller dies and you've got your relays there, yes you can pull them out and turn it into a regular standard old bypass type setup, but you've got to desolder and remove these. I'd really like to see EQD add maybe some bridged traces or something on the top of the board that can just easily bypass these with minimal sort of effort. That way, say for example, someone does own one of these in future and the microcontroller's gone or something along those lines, the company no longer exists, whatever, at least that gives them the ability to easily repair this and keep it going. Yes, you can do it, but if you don't have a half-decent desoldering gun and the likes and know what you're doing, it's a little bit more fiddly. Now, one thing we can see as well when we look through here is that we've got a couple of unpopulated pads, and we've also got some components that have multiple pads on top. So for example, this here, U3, which based on what I can see is an OP07, which is a good thing. We'll get into that in a moment. This can either be the DIP8 package on the outside or a standard SMD component there as well. Smart use, especially in this day and age of silicon shortages, and getting components is an absolute nightmare. Looks to be the same here as well. This looks to be something to do with a microcontroller. I'd assume it's going to be a stand-in for that. So if they can't get the SMD component, they can at least go for a standard DIP component. Smart thinking, it keeps these things in production. So you probably, if there's component issues or something in the future and you can't get a hold of them, there'll probably be different ones that have different components in those sections there. Not a big problem, not the end of the world. Let's take a bit of a closer look up front and see what we see on the board. So down here in the heart of the PCB, of course, we've got our relays, which what's kind of nice is that they are actually labeled so we can tell which relay does what job. So if you do need to troubleshoot one and repair one down in the future and you go, okay, this particular one isn't switching, you know which one to remove. This is a PIC18F microcontroller. This is going to be controlling all of this stuff here. However, it's also controlling this. So it's kind of what I was expecting, in that when looking through the manual and it says only connect the expression pedal when the pedal is off, that led me to believe that it's got something to do with a microcontroller controlling that octave control, and I was correct. This is an MCP4251, which is a digital potentiometer. What does that mean? That means that this inside of here has a control line, goes inside, and digital potentiometers, which allows us to control that octave effect using an external control without having to worry too much about any extra switching or anything along those lines. So we can connect up a control via the expression input to turn that octave up and down. Looking a little closer as well, if we look here, this is an OP07 op amp, which half the reason why a rat sounds the way it does, please don't at me when I use a bit of hyperbole in explaining something, is the OP07 or the LM308 were, by all accounts, if you're looking entirely from a design standpoint, were really, really terrible op amps for one primary reason. They had a very, very slow slew rate. What does that mean? That means how long does it take to get from its lowest voltage to its highest? It was painfully slow on the LM308 and on the OP07. They both have very similar, if not identical, slew rates. Because of that, that's what adds a lot of that sort of tonality to the upper harmonics and the likes in a rat circuit. There's a really, really cool breakdown for those who like super dry, super in-depth circuit analysis at electrosmash.com. I've linked it down in the description below, that goes through the circuit in massive, massive detail. He also does the tube screamer and fuzz face and a whole bunch of things. Really, really interesting if you've got a little bit of a more in-depth knowledge of electronics. Moving up into the top right corner of the pedal, we can see ourselves the clipping diodes. So we've got ourselves one LED, two silicons there, so that's going to be one half, and then of course the other two there, which are your standard anti-parallel clipping diodes for regular mode. So that's pretty cool. Unfortunately, unless you're really good with SMD work, you're not going to be able to change those out and make some interesting sort of tonal options and likes, like throwing in germaniums or whatever else, unless you're really, really confident in what you do. Moving over a little bit to the side, we can see ourselves a voltage regulator here. This particular one is a 5-volt voltage regulator, which would lead me to believe that probably the microcontroller is running on 5 volt unless there's something else on the other side of the board that's stepping it down to 3v3. So when EQD pedals say don't run them beyond 9 volts, it's because of the regulation inside and the voltage that's being created. Standard analog pedals that just have your op amps or whatever else inside of there can handle the extra voltage because they're still within their rated tolerances. But when you've got voltage coming in from here, that's got to be rectified through that and modified and whatever else and sent off there, or if you've got boost buck converters that control how much voltage goes to where, the moment you're feeding in more voltage, you're running the risk of damaging everything inside because it's expecting to see a certain voltage. Above that, maybe the regulator or the switch mode converter itself will blow up. Maybe it's not restrained, so it will output a higher voltage into the components there that are already running not too far away from their rated maximums. You know, some of them use a 9-volt input and then output 18 volts internally. So if you put an 18-volt supply in there, suddenly it's trying to take 18 volts and double it because it's just going to double whatever goes into it. 36 volts is going to be beyond the rating of most op amps out there, except for a select few. So definitely heed Earthquaker's warning when they say only use 9-volt supply on the pedals that say only use 9-volt supply. Now we'll move on over to the left side of the board, and this looks like the octave circuit. Yeah, I'd hazard a guess that's the octave circuit, because what we can see is we can see some transistors there, possibly FETs, maybe BJTs, not too sure, and a pair of diodes both facing in the same direction. That's a pretty common way of actually getting a octave up effect back in the day. They'd use a transformer, and what would happen is you'd have the wave going in both directions, and you'd use a diode on either side of that transformer with a center tap, and it would just push the signal forward and rectify each half of it. So that's how you'd end up with your octave up effect, and it sounded kind of weird and strident and all sorts of cool stuff. So I don't think we'll be seeing a transformer on the other side of this board, but maybe we will. First we'll have to pull it out and take a look, but I'd hazard a guess that's going to be the octave circuit there. Once again, it's all SMD, and it's quite small SMD as well. And finally, this looks to be the boost side of the circuit. So that looks to be the JFET with the corresponding supporting components, so resistors and capacitors ready to rock and roll, feeding into everything else there. And that looks to be the programming header, so they probably program these on board rather than having them pre-programmed from, I think, Atmel in this instance, it looks like. So I want to take a look on the other side of the board and actually see what's going on there, whether there's any other components hiding along those sides. So let's pull the board out and take a look. So with the board out, we take a look, and it's really nothing exciting. Just your standard sort of bits and pieces you'd expect on here. There's a little bit of Kapton tape still left down the bottom there from when they were doing some kind of work and the likes. The LEDs, of course, and the pots have been soldered by hand on the top side here. Can't exactly do reflow or anything along those lines out here. All standard sort of, 16mm pots there. Different pot there because, of course, that's a rotary switch, not a pot. So that's going to be doing its own thing, but, we're talking about the same footprint all in all. So now that we've taken a look and we've seen sort of the guts of it and what it's all about, I'd say it's a pretty solid pedal all in all that should hopefully sound pretty excellent. How will we know? Well, let's plug it in and find out. And there we have it, EQD Sunn Life Pedal V3. What do you think? Leave your thoughts down below in the comments. If you're after one of these pedals, of course, you can jump online, drgear.com.au, where we've got them in stock ready for shipping. Alternatively, if you like what we're doing and you think this kind of stuff's cool, then subscribe, leave a comment, hit the like and the notification icons and all that kind of good stuff. And until the next time, we'll see you then.